What we're going to show here is a simulated run of the Smart Engine Controller and Alternator Regulator. We've connected it up and powered it up. We have the LCD display screen, this service serial port attached to the service connector, our emulator, our simulated generator and DC battery. I've also connected an oscilloscope up to the simulated stator line so we can monitor the RPMs that are produced. And because we've enabled the debug flag inside the code, we can have a status screen displayed through the serial port. This allows me to display various debug information as well as control the keys. For example, one of the keys that I can do is press the next key, and that'll change the screen on the LCD display. If I continue to change next, we'll cycle through the engine one. This is the one that focuses on the alternator specifics. This one will eventually display water maker characteristics. And finally, we're back to the summary screen. I'm going to go ahead and start up the generator. Request that the unit enter generate mode. And you'll see it's reporting it's starting. Go through 2 start cycles. And about halfway through the second starter attempt, we'll go ahead and allow the machine to start. We're now running, and you can see that we're increasing the speed of the engine as indicated by the narrower time frame on the stator displayed on the oscilloscope. Also, you can see that the PWM is increasing. This is how hard we're driving the field. And the voltage is also increasing, you can see. As we continue to ramp up, we'll drive the alternator harder and harder, and the simulator will respond to that increased drive signal by allowing the voltage, simulated voltage of the battery to rise, as well as increase the number of simulated amps that's being produced. Okay, the oscilloscope showing that we've reached maximum RPMs. If we cycle through to the next display and focus on the engine, we can see that we're running almost at 3,000 RPMs. This is the maximum RPMs that we've configured this run for. There is a setup table that allows you to decide exactly how high you can run the engine, as well as the different steps in between the minimum speed and the maximum speed that you wish it to run. I'll go ahead and cycle back to the standard screen. At this point, we've entered the acceptance phase. Because of the simulation here, it actually ends up skipping over the bulk phase. We have condensed everything down in a very short period of time, so we end up skipping over the bulk phase. The simulator continues to accept the charge, and the battery continues to raise the battery voltage. You can see some oscillating on these 2 LEDs. Those are indicating the throttle control to speed up or speed down. That kind of oscillation is one of the things that I need to look at in the program and see how to lower that sensitivity as it's managing the throttle. As the battery continues to accept the charge, its acceptance rate for current lowers. This results in a lower number of watts being delivered into the simulated battery. With a lower number of watts being generated, the controller will recognize that and match the number of watts being requested and generated to the capability of the engine. And very soon we'll start seeing the engine starting to slow down. Matter of fact, if you look at the oscilloscope now, you can see that the waveforms are increasing. We've reached the minimum number of RPMs that we've configured the system to allow while still generating. We're still in the acceptance phase, still delivering a large number of watts. Soon the simulator will indicate that it has reached its full charge. The controller has decided that the battery is ready to enter the float stage. That's indicated by this last line here, alt stat equals 12. That last line is also something that was enabled due to the debug flag being defined in the code. I would anticipate during normal operation that would not be displayed. Okay, well there's an example of the run with the simulator. It's a very compressed run. In effect, the emulator is, if you will, a very small battery, so it did charge very, very quickly. But as I continue to debug the program and get to the point where it appears to be rather stable and try some longer time frame simulated runs, then I'll be looking to install it actually on our existing generator with battery.